Okay, today we're going to learn about the Pythagorean theorem. It's used to tell if we have a right triangle or to find the length of any side of a right triangle. This theorem is named after a guy named Pythagoras. He lived in Greece like 2,000 years ago, and he actually discovered something very interesting about the areas of the sides of a right triangle. And this specifically only works with right triangles, so that's something to keep in mind. The side of the right triangle is called the legs. If you take the area of a square that you would build here, and you were to add those areas together, it will always equal the area of this square over here. So he kind of made this discovery, and it helped out with lots of different things. What you need to do as an 8th grader is you need to be able to identify on a right triangle which of the legs, which is what's called the hypotenuse, this longest side here, and you need to know how you could also use Pythagoras' theorem to come up with measurements, missing values, determine if we really have right triangles. So, first things first, the formula is most commonly called a squared plus b squared equals c squared. Pythagoras used really easy values to talk about these two shorter sides, a and b, and then he just called this longer side c to keep it easy. We sometimes refer to these as the legs, so sometimes instead of a squared plus b squared, we're going to say leg squared plus leg squared. And instead of c squared, we might use the vocabulary word hypotenuse squared. So on your note sheet, what you're going to want to do first is label which is which. This is your hypotenuse. It's the longest side of any right triangle, and you'll notice it's across from this right angle over here. So that's how you can always locate it. Not only is it the longest side, but it's across from the right angle. The other two sides make up the legs. So this would be leg A and leg B. So once you know your vocabulary when you're working with a Pythagorean theorem problem or with any right triangle problem, you can move to the next step. So just to verify that we have everything correct, let's fill in the rest of the note sheet first. The parts of a right triangle are the legs and the hypotenuse. The legs are the sides that form the right angle. The hypotenuse is always a side across from the right angle, and it's always the longest side. You will always need a longer length to go from this end to this end. It'll always be longer than the other two sides that we have. So, before we get to some examples, let's make sure we understand how we're going to tell if we are given 3 side measurements, how we're going to tell if it truly does form a right triangle. Well, thanks to Pythagoras, we have a formula that we can use. So we are actually going to be checking to see if the first leg squared plus the other leg squared does actually equal the hypotenuse squared. And we usually abbreviate hypotenuse as HYP, hype. If you do not like using the vocabulary words leg, leg, hype, you can use the letters that Pythagoras used. We can use a squared plus b squared equals c squared, as long as you remember these are the legs, and c squared always has to be the hypotenuse. So what we're going to do with that formula is we're going to substitute numbers into the formula. We're going to do some math to simplify, and then we're going to see if both sides are equal. The most important thing, though, is remembering that the longest side is always that hypotenuse, that c value, and it's across from the right angle in every right triangle. So, if these side measurements truly formed a right triangle, then we would take the smaller measurements, these two would be the legs, and we would square them and add them together and make sure that it equals the longest side squared. So, what you will be required to do is start out with your formula. Pick the 2 smaller sides and substitute them in for the legs. Your longest side, remember, is always going to be your hypotenuse, or your C. Now, if you need to, you can use your calculator. 3 squared is really just 3 times 3. 4 squared is really just 4 times 4. 5 squared is 5 times 5. We are checking to see if these really are equal, so now you will simplify by working on the other math on this side of the equation. Turns out that 25 does happen when you add together your 3 squared and your 4 squared. So we know that yes, these 3 sides form the sides of a right triangle. We could sketch it here if you like. This would be 3, this would be 4, this would be the longest side or the hypotenuse of 5. Just so you know, that's really probably the most popular right triangle that we have. It's called a 3, 4, 5 right triangle, and it always works to be a right triangle because the a squared plus the b squared equals a c squared. Now we'll try these measurements of 8, 9, and 14. Always start with your formula so you have something to sub into. Always put your smaller measurements in for the legs, or the a and b value. Your largest value, remember, has to be your hypotenuse, so you'll make sure that you put your 14 over there. 8 squared is 64, 9 squared is 81. These add up to 145. Well, if we do our math on this side, 14 squared is 196. 145 is definitely not equal to 196, so what this means is your side measurements of 8 and 9 will not be connected with that 14 for your longest side. This cannot form a right triangle. And we could say not a right triangle. Sometimes you'll be working with just numbers that we want to check to be sides, and sometimes they'll make a little word problem out of it. So this one says Tina measures the distances between 3 cities on a map. The distances between the 3 cities are 45, 56, and 72 miles. Do the positions of the 3 cities form a right triangle? So as soon as you see anything about right triangles, you should automatically think about Pythagorean theorem. A squared plus b squared equals c squared. It will only work out that if we simplify the math and they equal each other, that this will be a right triangle. So again, smaller numbers go in for the legs, the a and the b. The largest side of 72 is going to have to be your hypotenuse for this triangle, if it is a right triangle. So 45 squared, if you use your calculator, you'll get 2,025. 56 squared, you should get 3,136. That combines to a total of 5,161. On the right side of the equation, we have to take 72 and square it, but you'll see that we get 5,000, but it doesn't match exactly. We get 184. So again, the cities do not form a right triangle. The only way they would is if this value simplified equaled this value simplified perfectly, like our first example.